So this is a study guide for your first test. Okay, let's begin. Identify the degree, the leading coefficient, and the name of the polynomial. Okay, so there are three things we need to identify here: the degree, the leading coefficient, and the name of the polynomial. So let's begin by finding the degree. The degree of a polynomial is the highest exponent. Okay, if one term has more than one variable, then we just add the exponents of those variables. So for example, here we have x squared, here we have x, and here we have no variables. So you could think of this as x to the 0 power. So the degree here, the highest degree is 2. So we would say the degree is 2. And so based on the highest degree, then we get the leading coefficient of that term. The leading coefficient is 5. And then the name of the polynomial, we would call it a trinomial because there are 3 terms. Okay, just like that. So let's move on to the next one here. So here again, we look for the variable with the highest exponent. So this would be the 2 here, the degree 2. The leading coefficient of this term here is 3. And since we have 3 terms, it's called a trinomial. Okay? This one here has 2 terms, so that would be a binomial. We'll get to that in a moment. So take a look here. This one has 2 variables, so that's y squared and then x to the first power. So add those up, you get 3. So degree here is 3. The leading coefficient is 6. And the type of the polynomial, it's a binomial. So what do you think this one would be? Okay. The degree would be 4. The leading coefficient is 6. And it's also a binomial. All right, let's move on. Remember, these are the types of questions that you will see on the test. All right, add. Okay, and you're allowed to use a calculator if you need it, so just have it there just in case. Okay, so notice here, this is add. There are plus signs in between each polynomial. So what we're going to do here when we're adding is we're going to go ahead and combine like terms. So it would be as if the parentheses were not there. So I can do it with the parentheses or without them. Just remember, parentheses are there to separate polynomials from one another, and sometimes they're there so that you can distribute the number on the outside, but this has no number on the outside that needs to be distributed. So I'm just going to go ahead and combine the 3x's here, the 3x there, and then the single x there. So 3 plus 3 is 6, plus 1 is 7, so 7x. And then we have the negative 2 and the positive 7. So in other words, 7 minus 2 is 5. That's my answer. Next. Notice here, we are subtracting here. There is an invisible 1 in between the minus sign and the parentheses. So we're really distributing a negative 1 here. So negative 1 times x to the 5th, I need to do that first. So that's going to be negative x to the 5th. Negative 1 times 3x to the 4th, that's going to be negative 3x to the 4th. And then finally, negative 1 times 2x, that's going to be negative 2x. Okay, bring everything else down. I don't need to include the parentheses, so the negative 17x plus 15 minus 33x squared. So now it's just a matter of combining like terms. So let's look for the one with the highest degree first. That one goes first. So notice here, I look at the exponents. It's the negative x to the 5th. That one's going to go first. I'm going to cross it out once I use it, okay? Next, it would be the negative 3x to the 4th. There is no other like term, so I just write that one as is, negative 3x to the 4th. Next would be the x terms here. So negative 2x and negative 17x, that's negative 19x. That's over with there. And then the negative 33x squared doesn't have a like term, so I just bring it down. And finally, the plus 15. So that's my answer. Okay. Notice the next one here. We have 1, 2, 3 polynomials, but the first 2 are being added, And then we're supposed to subtract the last term there. So we're going to distribute first. Let's do that. Let's distribute the negative. So negative 1 times x is negative x. And negative 1 times 5 is negative 5. Okay? Now let me go ahead and combine like terms here. And then I'll bring it down right next to the negative x minus 5. So 6x to the 6 plus 3x to the 6. That's going to be 9x to the 6th power. Let me cross those out. And then we have 3x squared and 7x squared. That's going to be plus 10x squared. And then 2x plus 1x, that's going to be 3x. Okay? Now I wrote this off to the side, but it's still part of the same expression here. So 3x minus x, just combine those two, and that'll be our final answer. So we have 9x to the 6 plus 10x squared, and then 3x minus 1x, that's going to be 2x, and then minus 5. Okay? All right. So far, so good. Okay, multiply. Okay, so now let's multiply. Remember, when we multiply, we use the box method here. So let's draw a 2 by 3. So 2, and then by 3. And so we have x plus 7, and then 4x squared, minus 6x minus 2. And so let's multiply. 4x squared times x is 4x cubed. Negative 6x times x is negative 6x squared. And negative 2 times x is negative 2x. This is the last row here. 4x squared times 7 is 28x squared. Negative 6x times 7 is negative 42x. And negative 2 times 7 is negative 14. A lot of negatives here. Okay? So let's combine like terms here. We have 4x cubed. Does it have any other like terms here? No. So we just write 4x cubed. Notice the x squared here. So it's 28 minus 6. That's 22x squared. Then we have negative 42x and negative 2x is negative 44x and minus 14. That's it. Okay. Find the area. So remember, to find the area of a rectangle, you just multiply base times height, or another way to say it is length times width. So let's do that. So it's pretty much going to be 8x plus 1 times 5x plus 2. You can write it like this. And then do the box method. Okay, so let's just do the box method. Whenever we're multiplying, the box method is the most organized tool to use. So we have 8x plus 1 and 5x minus 2. Remember, it doesn't matter where you put the 5x minus 2. It's a 2 by 2, so they could go wherever on this 2 by 2 box. Okay, so 8x times 5x is 40x squared. And then we have 5x times 1 is 5x. Negative 2 times 8x is negative 16x. And then negative 2 times 1 is negative 2. So let's combine our like terms. So we have 40x squared. And then here we have negative 16 and 5. That's going to be negative 11. I made a mistake here, so let me erase this. So it's negative 11x. And then minus 2. Okay? All right. Halfway done. This one's a little bit quicker. So notice here it says which two binomials. This should say have. Let me fix that. Which two binomials have a product that is a binomial? In other words, which two here can I multiply and end up with an answer that is a binomial? Okay? Now, you can try and multiply all these out individually. 2x plus 3 times x plus 4. Right? See what you get. And then try each one until you get a binomial. But if you remember what we talked about, factoring difference of squares, you'll remember that a difference of squares is something like x squared minus 9 or x squared minus 4, right? And so if you multiply these two right here, x plus 4 times x minus 4, what will you get if you multiply these two? Let's do the box method for this one so you can see. Some of you already know, but some of you don't. So let's go ahead and do this. So x plus 4 and then x minus 4. Watch this. X times x is x squared. 4 times x is 4x. And then negative 4 times x is negative 4x. And then negative 4 times positive 4 is negative 16. What happens to these two? That's right, they cancel out. So I'm left with x squared minus 16, which is a binomial. Okay? So again, it would be those two binomials that you could multiply and end up with a binomial. Okay? Now what about these here? And again, I need to fix this. Which two binomials have a product that is a trinomial? So now notice here, it's being asked almost the same way, except instead of a binomial, now it has to result in a trinomial. So would you pick the x plus 4 and x minus 4 again? No, you wouldn't, because you would end up with a binomial. So you need to make sure that you pick any other two binomials, okay? Notice there's a monomial here. If you were to multiply 5x times one of these, let's just do that. 5x times x minus 4. Would you end up with a trinomial? 5x times x is 5x squared. 5x times negative 4 is negative 20x. So notice here, this is a binomial, okay? But you may be wondering, wait a minute, then why didn't we choose those two for the answer above? Well, why do you think? Is 5x a binomial? No, it's a monomial. Mono means one, M-O-N-O, it means one. And so this would not qualify here for where it asks which two binomials. So we need two terms. This is one single term here. Okay, so this wouldn't work. And so in reality, it's any other two binomials other than x plus 4 and x minus 4. So you could even use these two. So 2x plus 3 times x plus 4. Or 2x plus 3 times 3x plus 3. Or x minus 4 times any of these except for x plus 4, okay? So there are other options there, but just make sure you pick two binomials that are not opposites. All right? Almost finished with our study guide here. Can x squared plus 25 be factored into x plus 5 times x plus 5? Why not? So this looks almost like a difference of squares, except it has a plus sign in between. If it were a difference of squares, it would be x minus 5 times x plus 5. But this says x squared plus 25. So can it be factored into this, x plus 5 times x plus 5? Let's see if multiplying those two gives us x squared plus 25. Let's do that. X plus 5, x plus 5. Let's see. That'll be x squared plus 5x, right here, 5x, and 25. So we get x squared plus 10x plus 25. Notice we end up with a trinomial, not the binomial that they said. So the reason we can't is because these will give you a trinomial, okay? So that's the reason why x squared plus 25 cannot be factored into x plus 5 times x plus 5. It's just not the correct pattern. Okay? All right. Factor. This here is a difference of cubes. Now remember, 64 is a perfect cube. If you do 4 times 4 times 4, you get 64, which makes 64 a perfect cube. So notice here I multiplied 4 times 4 times 4. That's the same as saying 4 to the third power. Okay? And then we have x to the third power minus, and then 1 is 1 to the third power. Okay, I can say 1 times 1 times 1 and still get 1. So to factor this, remember it's going to be a pattern. We're going to go ahead and factor here the 64x cubed minus 1. First, we need to just get the basis. So we have 4x here, 4x minus 1. Now the rest of this parentheses comes from these 2 here. So remember, we take the first term here and square it. So 4 squared and x squared. So that'll be 16x squared. Again, 4 times 4 and x times x is 16x squared. This will be plus sign here. And multiply these two. 4x times 1 is just going to be 4x. Again, ignore the minus. We're just multiplying the 4 and the 1 right now. The 4x and the 1. And then finally another plus sign there. And then we just raise that term to the second power. So 1 squared is just 1. Okay? Next, we get into regular trinomial factoring. Remember? Just jump straight into factoring. Just split this up. That's x times x. And 25, well, there's two ways we can make 25 by multiplying. 25 times 1 and 5 times 5. But which one will give us the negative 10 that we want? Well, the 5 and the 5, as long as they're both negative. Let's put minus 5 there and minus 5 there. Notice we still get the positive 25 at the end. All right. 3 more to go. And this is the last one here, okay? So 5x to the 4th minus 50x cubed plus 125x squared. Again, we're factoring here. First thing I notice is they all have an x, and they are all divisible by 5 because they end in 5 or 0. Okay? So that means I can factor out a 5x squared. So what am I left with when I factor that out? Well, 5x squared times x squared will give me 5x to the 4th. Remember, we're undistributing here. And then 5 times what is 50? Oh, we know it's 10. So 5 times negative 10, right? That'll give me the negative 50, but I need x cubed now. I have x squared only, so that means we need one more x there. What about 125? I know it's divisible by 5, so let's do 125 divided by 5. That's 25. So it's a positive 125, so I just make positive 25, and I get 5 times 25 is 125, and I already have the x squared there, so I'm done. Now notice, we just did this in the problem before. So look at how you factor that one, and that's the same factorization. So we're going to factor this into x times x. And then we need to make 25, but we also need to make negative 10, so that's going to be negative 5 and negative 5. Again, negative 5x and negative 5x make negative 10x. Okay? 2 more to go. Factoring by grouping. Whenever you have 4 terms, try factoring by grouping. So remember, we're going to go ahead and factor in groups of 2. So what do these two have in common? Well, they have x squared. So we're going to factor out x squared. That's going to be x minus 2. Okay? Plus, if this were negative, we would put a negative there. But let's see here. We're going to go ahead and put x minus 2 here. Okay? Because we are assuming that they can be factored by grouping, so that these two parentheses, they must match. Okay? So then what would I need to factor in order to keep this x minus 2? What would I need to put outside here so that I end up with x minus 2 when I distribute? Well, looks like it's just a 1. I don't want it to change, so I'm going to put a 1 there. 1 times x is x. 1 times negative 2 is negative 2. Okay? So now I have x squared plus 1. Those go in the single parentheses. And then this one goes here. Now, can I factor this further? Is this a difference of squares? No, it's not. It's not a difference of squares. What makes it not a difference of squares? That's right. That plus sign makes it not a difference of squares. Difference refers to subtraction. That's not subtraction, that's addition. Okay? And finally, x to the 4th plus 5x squared minus 14. Now this is a trinomial. Notice here this exponent here is even. That means it's a perfect square. And this is half of that. So that means we can factor it using the trinomial method. So we're going to split this up into x squared times x squared. And then 14. I know it says negative 14. Let's put a negative there. We're trying to make 5. So 7 times 2 is 14. Can we get 5 out of this? We sure can't by subtracting. So just do 7 minus 2. That'll give me the positive 5. So there you go. Plus 7 minus 2. Now check to see if any of these can be factored. That's not a difference of anything. And this is a difference, but that's not a perfect square. So I'm done. And that's it, guys.